All right, well, we're in the middle of a bell work question, but we'll keep going. In bell work here, U substitution, we made this our U. We made that U because of this exponent right here, not the denominator, because if it was the denominator, nothing would cancel out with that E. So we made that my U is x to the 1/2 power. We then took the derivative of that, so we made it 1/2 x to the negative 1/2, and since x is negative 1/2, we can put it on bottom. Cool, we did all that. We still got to find our new upper bound and lower bound. What am I going to do, Macy, to find my new upper bound? Plug it into what? The U. Good. We're taking that 1 and that 4, and she's plugging in right here. So it's the square root. The square root of 4 gets me 2. I take 1, I plug it in. Square root of 1 gets me 1. Everybody good to there? Then we just do the setup. We're integrating. We are going from 1 to 2. It is e to the u, because, again, that's why we picked that all over. On bottom, we've got square root of x times, instead of dx, I'm going to plug in what dx is. Dx is 1 over 2 square root of x. Oh, I lied. I didn't finish that. My bad. I got distracted by having to record. We got to multiply by dx and multiply by that, so it's really 2 square root of x du equals dx. So times that by 2 square root of x du. If I did it right, I got some things that should cancel. Whew. All right, I'm back to normal. All right, if we did it right, we have some things that canceled. If I did it right, my x's cancel. Is that happening here? Yeah, better. Otherwise, we picked the wrong u. So that square root of x, that square root of x are going to cancel. I've got this 2 right here. It's a constant, so I could pull it out in front. So we're integrating from 1 to 2. EU, du. Trying to figure out which one's the same as that. Boom, it's C. Make sense on how we did that? Cool. We'll do some whiteboards later, but for right now, pull out an internet-capable device. Let's play some Kahoot. All right, I'm going to record mid Kahoot here. Since the u is 5x plus 2, we can just do a mental u sub because the derivative would just be 5. What is the antiderivative of e? E. You rewrite the exponent, and then you are going to divide by the derivative of my exponent. That's where I'm getting the 1/5 from. Next question. Integrate the following using u sub. Mental u sub would be even better. All right, let's see how we did. We're integrating here. Again, the u would be the 3x. Since it's the derivative would just be a constant, we can do mental u sub. 4 is a constant. What's the antiderivative cosine? Sine. So it'd be 4 sine 3x, but then you have to divide by the derivative. That's why we're getting 4/3 sine 3x plus c. Mental u sub. You don't have to do it this way. Okay, if you want to write it out every time, great, but you better be really good at writing it out because it's going to take you a while. Next question. You are trying to integrate. See what you can do. All right. Well, we are half, not even half right. Yeah, it was worth a try. 4 over x minus 2. Okay. Do we have any constants? The 4 is a constant. The u would be x minus 2. Okay. And so it would be like 1 over u. What is the antiderivative of 1 over u? ln. That's why I'm getting this one right here. 4 natural log of x minus 2 plus c. We don't need that negative sign. The blue one has a random negative sign that's thrown in. We don't need that here because the derivative of x minus 2 would just be 1. Integrate using u sub. Mental u sub is perfectly good here. Good job, everybody. The antiderivative of e is what you see, and then you just have to divide by the derivative of the exponent, which is dividing by negative 1/3. So negative 1/3 e to the negative 3x plus c. Wonderful. Let me hit pause. That one was missed a lot today. That was way better than most of my classes, to be honest. -4, that's a constant. What is the antiderivative of sine? Negative cosine. So the two negatives make this thing a positive. So it's going to be +4 cosine 2x. And then I got to divide by the derivative. So then I got to divide by 2. That is why I get a positive 2 out in front of everything else. Next one. Couple left. Integrate. I'm giving you 50 seconds. I'm not giving you that whole time. All right. Not too bad. A couple of us missed it here, and they all missed the same thing. Everybody has the right setup. Why do I need to have a negative sign and not positive? The x is negative. Because think about, if this is my u, what's the derivative of the bottom? The derivative of the bottom is going to be -1. That is why I have a negative in front of everything. Okay, a little bit tougher. Integrate it. Again, I'll give you about 45 seconds.
Way to go, Macy.
Here we go. Looking at this one. Secant squared. Cool. What's the antiderivative of secant squared? Tangent. You rewrite the baby, so tangent of 5x, and then you got to divide by the derivative of the baby. That's why it's 1/5 tangent 5x plus c. You got to include the 5 if you pick that one, and then that one is 1/5. Oh, man, Fred. Let h be a continuous function using substitution. U equals 3x plus 5. What is the following integral equal? It's not that bad. It looks harder than it is. Think about it. It's kind of mental, Usub. Good deal. So we look at this thing. If this is my u, what am I going to have to do with my bounds? Plug them in. If I plug in 0, I get 5. If I plug in 4, I get 17. And then the derivative of this is 3. That's why I got the 1/3 in front. That's my answer. Let's play another one. There we go. We are playing again. Same type of questions. This time a little bit more U substitution based. Instead of mental U sub, you got to actually do some U sub. What is the U in the integral? You don't need to write a whole lot here still. Let's check. U sub 4x squared plus 6. What would the derivative of 4x squared plus 6 be? 8x. It's that one. We don't want to include the square because if you include the square, it gets kind of ugly. We don't want to do that. Next. What would you substitute in for dx on this problem? A diamond, perhaps? We look at this guy. The derivative is, or the u is going to be 6x. So if we're getting dx by itself, it'd be du over 6. That's what I'm looking for there. Du over 6. Next one. What is the u? The u, if you just have e, pick the exponent, because what's the derivative of 2x squared? 4x, which would cancel with that thing. At least the x's would cancel, and that's what I really care about. That's why we picked 2x squared. Next one. What are the limits in terms of u? Careful here. Make sure you identify your u correctly. All right, here we go. What's our u going to be here? X squared. Don't include the cosine, because if we include cosine, it's not going to cancel with anything. It's just x squared, so then all you have to do is plug in your bounds. So square root of x squared, or square root of pi squared, would get you just pi. That's why I'm picking the yellow one. What would the substitution for this be? So you're going to go ahead and figure out what u is and then plug in and see what you can do. Yeah, it is. It's weird. All right, sine of 3x. So this is going to be my u, and then the derivative would include a 3. So the 3 would go on bottom. That's why I'm getting the 1/3 sine u du. Next one. What are the limits in terms of u? So you're just trying to figure out limits. Don't overthink it. It's not as hard as it seems. Wonderful. The u is going to be the part on bottom, so it's just this x squared minus 3x plus 1. Then if you plug in 3, 3 squared is 9. Minus 9 would be 0. Plus 1 would be 1. So your lower bound is going to be 1. It's the only one with 1 in it, so that's why I push in. What is the integral with the u substitution? So you're trying to figure out what would it look like when I plug in. What would my u be here? The whole bottom. So the bottom is my u. The derivative of the bottom here would be what? 4x. So you would be dividing by 4x, which is going to cancel with that 4x on top. That is why you're left with simply du over u. That one's a little tougher if you're not writing it out. And normally you would write that out. Don't listen to the directions. Just integrate. Solve it. You got a whiteboard in front of you if you need it. You can work on that there. Here we go. If we solve this problem, what would my u be here?
E tangent x.
I want to pick just the tangent x. If I pick e, then nothing's going to cancel with the e. If I pick it secant squared, the derivative is not going to cancel. But I'm going to pick u to be tangent x. That means du over dx is going to be secant squared. And then when I solve, it's going to be du over secant squared x equals dx. And then if I plug this guy in, it's going to be e to the u secant squared x. And then it's going to be times du over secant squared x. Those two things are going to cancel. Then all I got to do is integrate e to the u. What is the antiderivative e to the u? E to the u. So it would just be, act like I didn't write that, e to the tangent x. I'm going to plug back in what u is, plus c. That's why my answer was that guy. Woo! Glad I did that one. We needed that work. All right, shifting gears here. We're just going to do some whiteboards. There is a whiteboard question on the board. You're integrating from 1 to 3, x over x squared plus 1. See what you can do. All right, so I did this problem. It's different than the ones I've done earlier today. I want to show it to you here because it's a good question. I wish I would have done this with my other classes. My u is going to be x squared plus 1. My derivative is going to be 2x. When I solve it, it's du over 2x is equal to dx. Everybody good to that point? Okay, upper bound. I take 3, I plug it in. 3 squared plus 1, it's 10. I take 1, I plug it in. 1 squared plus 1 is 2. We got bounds. We're going from 2 to 10. X over u, and instead of dx, I'm going to plug in du over 2x. These guys could cancel. There you go. We're integrating from 2 to 10, 1 over u du. It's weird, but we can do that. What is the antiderivative of 1 over u going to get me? Natural log, absolute value. Don't go back to x. We already went away from x. We don't need to go back to x. It's the antiderivative is natural log of u, and we're going to integrate that thing from 2 to 10. Don't forget about this 2 that I randomly forgot. Still going to be a 1/2 in front. And then look at this final answer. Okay, they like to do this on the AP exam every once in a while, and it's something that you have totally forgotten, but they are mean, and they put it in there anyways. Upper bound minus lower bound. Anybody know what that would simplify into? Natural log of 10 minus natural log of 2. It is not. It is natural log of 5. Anybody remember why it's natural log of 5? When you are subtracting logs, you can divide the arguments. Okay, so it's 10 divided by 2. That's where I get 5. It's a weird thing that they throw at you every once in a while. I'm not throwing that on your quiz tomorrow, but it's a good thing to remember. A skill that you've forgotten that you'd learned in Algebra 2 and Pre-Calc. You don't anymore because the absolute value of 10 is 10. And so if it were negative 10, then yes, it would become positive 10. But I technically took the absolute value by plugging them in. That one's hard. That's okay. Let's try the next one. We're setting this thing up. Why did I pick sine and not cosine? It's cubed. So we're setting this up. We picked sine. We found the derivative. We found that. So now we get cosine x over u cubed. And instead of dx, I'm going to plug in du over cosine x. If I did it right, my x's are going to cancel. They do. Okay. I am then left with just the integral of 1 over u cubed, or u to the negative 3. We take the antiderivative. So we add 1 to our exponent. We divide by our new exponent. And then I just fill in what I need, negative 1/2. Instead of u to the negative 2, oh yeah, that's sine to the negative 2 plus c. One more. I did a bad job with time management today. Let's try one more, see if you can figure out that one. That's one of their favorite multiple choice questions. See what you can do. All right, I'm going to start this, or we're not going to get it before the bell rings. My u, what's my u going to be? That whole thing. 2 ln of t is on top. That's my u. And then it's du over dx. The derivative of 2 natural log is going to get me, oh, I wrote that all wrong. 2 plus natural log of t. Derivative of 2 goes away. Derivative of natural log is 1 over t. Okay, we solve it. We get du times t equals dt. I got to find my new upper bound and my new lower bound. And so I'm plugging in e. What is natural log of e going to get me? So it's 2 plus 1, which is going to get me 3. If I take 1 and plug it in, natural log of 1 is 0. So this is going to get me 2. I integrate from 2 to 3. I get u cubed on top over t. And then this part right here becomes t times du. The t's are going to cancel. The antiderivative of u cubed is u to the 4th. Oh, I don't need to do any of that. Never mind. We got an answer right there. That one. Kind of weird. Tomorrow we're going to take a quiz. Make sure you're ready for it. The things we did today will make you ready for it. From there.